Hey there, good morning. It's time to do one last review before your quiz tomorrow, and then a nice long Easter break. I hope that you're ready to celebrate and work, and also to get closer to God during this time. All right, so let's get right to it. We're going to run through the questions. I'm going to do some brief explanation. If you need help with any of the specific concepts, you can always go back over and really take it slow as far as watching the videos on section 6.5 to 6.7. That stuff that we had in section 6.8 is not going to appear on this quiz. Okay? All right, so here we go. So when we solve, first of all, if you're solving a radical expression, don't forget you look at the index to find out what to do in order to get rid of it, because you're going to do the inverse, which an inverse of a square root is a square. So when you square both sides, it has the effect of getting rid of the square root. And then squaring this is 49. You do the regular math that you add 5, you divide by 2, and you arrive at your answer. Like I said, I'm going through these quickly, so slow it down if you need to. I know that that's an option. All right, so here we go. When you have a fractional exponent and it's already isolated, you can get rid of that by taking it to the reciprocal power. And when you take it to the reciprocal power, the effect is when you multiply these, we get a 1. So when we do this, remember this is the index and this is the power. So we look to see if we take the index, if that's going to be helpful, and it will be. 3 to the 5th power can be done out either by hand or by calculator to find out that it's 243. And then, of course, subtracting 10 from both sides gives you your final answer. To undo a cube root, you cube it. So we're going to cube both sides here. And once we have done that, 2 cubed is 8. Be careful with that one. Add 12 and get 20. Okay, like I said, if this is going too fast for you, go back and watch the slow explanation on the original video. This is just a quick review. Do it at your pace. All right, sometimes we've got to make sure that we're checking our answer. I know I didn't really do a good job on the prior ones, but comes up mostly when things get more complicated like this. So we're going to square root x plus 5. In order to get rid of the square root, we know we need to square it. This one takes a little bit more effort, because when you square x plus 3 times x plus 3, you can do that out slowly on paper to convince yourself that it's x squared plus 6x plus 9. Since we have a quadratic, you need to bring all of the values over to one side by taking away x, by taking away 5, and you have this. This is factorable. Always check for factorable first. So it factors to x plus 4, x plus 1 is the factors of 4, that when you add them that give you 5 are 4 and 1. Gives us 2 possible solutions. Notice I have one circled and one not. That's because when you plug it back in to check, all right, square root of 1 equaling -1. Well, this one is looking for the principal when there's nothing out in front of it, so we've got to be careful with that. So no, that one doesn't work. But when you plug in the -1 as an answer and you get the square root of 4 equals 2, that one works. So this one's extraneous, which means it's not really a solution at all. But x equals -1 is your actual solution to that one. So always do all the work, check. There may be one or more that do not work, but they might both work too, so make sure you check them. All right, then we have the functions where you need to be able to add them, subtract them, multiply them, or divide them. I just have the ones that tend to be a little bit more complicated here, but just make sure that you know that if there's a plus here, you would add the 2 functions, and if there was a times, you would multiply them. But I'm just running through some basics here. All right, when you subtract the functions, you're going to take the first function minus the second one. Key part is don't forget to distribute your negative. And then when you put together your like terms, remember that a square root can't go with a non-square term when you're adding or subtracting. We need to consider the domain, and I know that in the questions when I looked at them, one of your key sticking points was figuring out the domain. Remember, the domain is the values that are allowed to be chosen to be an x. So we look at this, and the only thing, there's no denominators to deal with. However, since we do have a square root of x in this mix, you have to be careful and say, wait a minute, this number can be 0, it can be positive, but it can't be negative. So our domain is all x such that x is greater than or equal to 0. Less than just doesn't work. When you divide, okay, this one cannot be simplified at all. There's no radical in the denominator. There's nothing to do besides just put the one over the other. You do, of course, look to see if it can be simplified. We look to check for the domain. Now we have two things happening here. One of them is that x plus 9 can't be 0. So that's one thing to take a look for. X plus 9 can't be 0. However, the other thing is that we still can't have anything that's negative at all. So really what you could do here is just say this one, because that covers also that it can't be negative 9. But I did choose to show both here simply because I always want you to consider the denominator, because the denominator can't be 0, and then you also have to look for things like square roots to find any restrictions. I wouldn't have a problem if you write both of these, even though this part up here is redundant, because x not being negative 9, of course not, because we already said it had to be greater than 0. But I also don't want you to miss anything. Okay. All right. Remember, this does not mean times. If we mean times, it's got to be just plain a raised dot. This means it's a composite function. All right. So that means that in this case, you're going to do the g of 5 function first. And then whatever you get, you'll find the f value for that. So let's take a look at that. We find g of 5 first. G of 5, 5 squared minus 4 is 21. So then you take what you got for that and put it into the f function and get 61. Okay. This one, you do the f function first. So we're going to take a look at what you get for f of negative 3. You plug in 3 times negative 3 minus 2. That gives you negative 11. Then after that, you've got negative 11 here, so you're finding g of negative 11. You plug it in and finally arrive at 117 by doing that work right there. So your final answer to this question is 117. All right, this one, when you have a variable, remember you're taking g of x first, okay? Here's g of x, and you're taking the f function of g of x. So that means in the f function, wherever you see x, you're replacing it with this. Okay, this is maybe one of the trickier things, so I want to make sure I highlight this. This gets put in right here where the x is. So this gets plugged in here. So when you do that, we have 3 times x squared minus 4, because that's what the variable is here. And then you distribute it, and then you put your like terms together, And your final simplified answer is 3x squared minus 14. So just be a little bit careful with that. Then we have inverses. So you'll be asked to find inverses. Remember inverses, you switch the x and the y. So the x becomes the y becomes the x, and then you solve for y. So x plus 18 is 9y because you add 18 to both sides, divide by 9. You get 1/9 x plus 2, so our inverse function is y equals 1/9 x plus 2. All right. A little bit more, the inverse, sometimes we can have it in function notation. So when we do this, our inverse function of this, we take this to be a y, the f of x becomes a y, then switch your x and y. So this becomes x, this becomes y. Then solve for y. And when we use a square root to simplify a square, you have to use the plus or minus version of it because every value has to be taken care of. Think about this as being a parabola, and when you change it over, you can't just have half when it turns on its side. You have to have the plus version and the minus version. If you think about that graph to help you unravel that as far as why you need a plus and minus. And so our inverse function is plus or minus the square root of x plus 8. Okay, so we've got that. Now, this one, think about the shortcut. Not any kind of fancy plugging in. An inverse undoes the original function. As long as this doesn't hit any of the restrictions, 28 isn't going to mess up anything in either one of them. So our answer is just 28. F of f inverse is going to be 28. I'm not trying to fool you on that. I'm trying to get you the idea of inverses. So don't overthink this one. Just kind of be automatic in writing in your answer. All right, that's it for today. I want you to make sure you're studying, make sure that you're ready to do a good job on your quiz tomorrow, and then ready for a nice relaxing break. God bless you, and have a great day.